Hey everyone, and welcome back to my channel. Today, we're going to be discussing the inverse trigonometric functions, also known as the inverse sine, inverse cosine, and inverse tangent. So, a quick refresher from our last session. You might remember that there's this acronym called SOH that basically tells us that sine of an angle is equal to the opposite over the hypotenuse, the cosine of an angle is the adjacent over the hypotenuse, and the tangent of an angle is the opposite over the adjacent. Now, if we have an angle and any one of the three given sides, right? If we have the hypotenuse, the opposite, or adjacent, and we want to solve for either the hypotenuse, opposite, or adjacent, we can do so with any one of these three functions, depending on, obviously, what variable is inputted and what variable we want outputted. However, what if we want to solve for an angle and we're given two sides? Well, this is where the inverse trigonometric function comes into play. So, if we know the opposite and the hypotenuse, but we don't know what the angle is, we can use the inverse sine to solve for that. The same logic is true for cosine and tangents, where with cosine, you know the adjacent and the hypotenuse, and with tangents, you know the opposite and the adjacent. So, let's start with this example right here. You might remember from our last video that this was the first example that we did for SOH, and it's the first example that we're going to do for inverse SOH to try and get back the angle that we started with. So here we have two different sides. So my question to you is that relative to the angle, are these sides the adjacent, opposite, or hypotenuse? Well, let's start with 10. 10 is going to be opposite to this right angle there. So we can deduce that that must be the hypotenuse. So hypotenuse is equal to 10. And 6 is going to be opposite to the angle, so we find that the opposite is 6. So if we're looking for a function that relates the opposite to the hypotenuse, that's going to be sine. So we're going to get sine of an unknown angle theta is equal to the opposite over the hypotenuse. However, remember that what we want to do is solve for the angle theta. So what we're going to write instead is theta is equal to the inverse sine of the opposite over the hypotenuse. Okay, so now we can plug all of our variables in, which is going to give me theta is equal to the inverse sine of 6 over 10. Now, you can simplify that fraction to 3 over 5, but it's not going to make a difference for the end result here. We're going to get that theta is equal to 36.86 degrees, or we can round that to 37 degrees. So therefore, the angle theta is equal to 37 degrees. Okay, so moving on to the following example, we have an opposite side of 4.83 and an adjacent side of 4.21 relative to the angle alpha. So I'm going to get opposite as being 4.83 and adjacent as being 4.21, where the angle alpha is my unknown. So what this tells me is that I should be using tangent. So I'll write that tangent of alpha is equal to the opposite over the adjacent. And we specifically want the formulation where we solve for alpha. So we're going to go alpha is the inverse tangent, or tan minus 1. That's probably how it's written on your calculator, as being equal to the opposite over the adjacent sides. So this is going to give me alpha is equal to the inverse tangent of 4.83 over 4.21. And this is a bit of a difficult one to simplify, so we're not going to bother with that. We're just going to plug it right in. And what I get is that alpha is equal to about 49 degrees. And usually with angles, you can round them to the nearest whole number, and that's okay. Okay, so I would like to start with this example here. As you can see, there are two different angles, A and B, to solve for. And this is what our problems are going to start to look like as we get to more and more complex problems, is that there's going to be more angles and more sides to solve for. So let's start by solving for angle B. You could start with angle A, but that's just the one that I randomly chose to do. So relative to angle B, I know that my hypotenuse is going to be equal to 3.8, and my adjacent side is going to be 3.3. So this tells me that I should use that the cosine of b is equal to my adjacent over my hypotenuse, or b is the inverse cosine of the adjacent over the hypotenuse. Okay, so this gives me b is the inverse cosine of 3.3 over 3.8, or as a final answer, b is equal to 30 degrees. Now, to solve for the angle A, we could use the inverse SOH, right? In this case, because we know the opposite and hypotenuse, we would use sine. However, we could also use our angle sum theorem, if you remember that. So, I'm going to get 180 degrees is 90 degrees plus b plus a. Well, we know that b is equal to 30 degrees. So that's going to give me 180 degrees is equal to 90 degrees plus 30 degrees plus a, or 180 degrees is equal to 120 degrees plus a. Subtracting 120 from both sides, we get that 60 degrees is equal to a, and that gives me my final answer for both the angles b and a. Okay, so what we have here is a side that's unknown, an angle that's unknown, and we have two given sides and one given angle. Then we have a third angle that we don't care about for the time being. So, using our tricks, we're going to go ahead and solve for this triangle. So, to start with the angle gamma, what we find is that 5.7 is opposite and 4.1 is adjacent. So my opposite is 5.7 and my adjacent is equal to 4.1. So what I'm going to get here is that tangent of gamma is going to be equal to opposite over my adjacent side, or gamma is equal to the inverse tangent of opposite over adjacent. So this is going to give me gamma is equal to the inverse tangent of 5.7 over 4.1, or that gamma is going to be equal to 54 degrees. Now, to solve for the side C, there's two different ways that I could do this. So I'll write down what these two ways are. So first off, I can use SOH. So in this case, I can go ahead and use either sine or cosine to solve for the angle. So I'm going to say that the sine of gamma is equal to the opposite over the hypotenuse. The hypotenuse is unknown, and we know to rearrange for that. We get that the hypotenuse is equal to the opposite over the sine of my angle. So now I'm going to replace all of my variables. My hypotenuse is c, so c is going to be equal to the opposite 5.7 divided by the sine of 54 degrees. Well, this is going to give me that c is equal to 5.7 divided by 0.8118, or that c is equal to about 7.02. Now, the second way to do this is going to be using the Pythagorean theorem, right? We know two of our sides, and we want to solve for the third side of a right triangle. So 2 Pythagoras. And this is going to give me 5.7 squared plus 4.1 squared is equal to c squared. So 5.7 squared is going to give me 32.49, whereas 4.1 squared is going to give me 16.81. So that's equal to c squared, which gives me 49.3. So 49.3 is c squared. Now I'm going to take the square root of both sides, which is going to give me a final answer of 7.02, for C. So you can see here that either way that you choose to solve it is perfectly acceptable and is going to give you the exact same answer. Okay, so this problem right here is really the accumulation of the past 4 videos and the content that we have covered. So using the tools of the angle sum theorem, Pythagorean theorem, and SOH, you don't have to use all the tools. I just wrote out what was available to you. I'll get you to go ahead and pause the video if you're interested, try to solve it, and come back when you're ready. Okay, so in terms of what we can start with here, I'm going to go ahead and start by solving for the angle E. So relative to the angle E, I'm going to write here 1, solve for E. What I know is that the opposite side is equal to 1.7 and the adjacent side is equal to 1.2. The hypotenuse is going to be equal to D, which I don't know yet, so I can't use that as a variable. So what I find is that E is equal to the inverse tangent of the opposite over the adjacent. Well, here, that's going to give me that E is equal to the inverse tangent of 1.7 divided by 1.2. Or, as an answer for the angle E, I get that about 55 degrees is E. So from here, what I can do is I can go ahead and solve for the angle F. So I'm just going to switch up my color to solve for F. And we can just use the angle sum to do this. So 180 degrees is equal to 90 degrees plus 55 degrees plus the angle F, right? 90 degrees because of the square there, and 55 degrees because of this angle E that we just solved for there. So that's going to give me that 180 degrees is equal to 145 degrees plus F, or that 35 degrees is equal to F. And finally, we can use the Pythagorean theorem to solve for the side D. So solve for D. Well, what we get is that 1.2 squared plus 1.7 squared is equal to D squared. Well, that gives you 1.44 plus 2.89 is equal to D squared. Now, that's going to be equal to 1.44 plus 2.89, 4.33, as being D squared. And I take the square root of both sides, which is going to give me a final answer of 2.08 as being D. So, now that we have discussed all 3 of these techniques, you can see that the triangle is completely solved. Okay, so we have the exact same concept here, where we have one side and one angle. So, using SOH, Pythagorean theorem, or angle sum, or inverse SOH, whatever you feel is comfortable and the right path, go ahead and solve this triangle. Alright, so the solution set that I came up with is as follows, but if yours differs in terms of the order, that's perfectly okay, as long as you get the same answers. So the first step is that I'm going to solve for theta. So what I get here is that 180 degrees is equal to 90 degrees plus 30 degrees plus theta. Or 180 degrees is 120 degrees plus theta. Now this gives me 60 degrees as being my angle there. Okay, so my second step is going to be to solve for y. So in terms of how we can do this, we have this angle 30 degrees and an angle 60 degrees. I'm going to use 30 degrees because that's what was given initially. And I have this adjacent right here, which is equal to 1. And then I have this hypotenuse over here, which is an unknown. So if I have my adjacent as being given, my angle, which I'm going to call beta here, as being 30 degrees. and my hypotenuse as an unknown. That is exactly the situation for cosine, right? So cosine of beta is equal to my adjacent over my hypotenuse. Now I'm going to isolate for the hypotenuse, which gives me the hypotenuse is going to be the adjacent over the cosine of beta. So this is going to give me that my hypotenuse is equal to 1 over the cosine of 30 degrees. Well, the cosine of 30 degrees is going to be equal to 0.8660. So therefore, my hypotenuse, or y, is going to be equal to about 1.15. And the final step of this is that we are going to solve for the side x. So x squared plus 1 squared is equal to y squared. Well, to isolate for x, this gives me x squared is equal to y squared minus 1 squared. So x squared is going to be equal to 1.15 squared minus 1. Well, 1.15 squared is going to give me about 1.3. So 1.33 minus 1. So x squared is going to be equal to 0.33. Now, at this point, I want to take the square root of both sides. And that's going to give me that my x value is going to be equal to about 0.57. So, just like that, we have solved the triangle. Okay, so thank you very much for your attention, and I hope that you found this video valuable and informative. Stay tuned for another video coming shortly on some problem sets for this.